The sides of a triangle are 6, 10 and x. We need to find that value of x for which the area of this triangle is maximum. We have a couple of options. We just have to choose the right answer. Now, before we solve this question, I came across a very interesting but wrong answer. I will share it with you. Tell me why it is wrong. Now, when two sides are given, we know that the third side lies between the difference and the sum of these two sides. Then out of the options, which one do you see is closest to 16? It is 15.8. So is 15.8 the correct answer? The answer is no. Can you tell me why it is the wrong answer? When you choose the longest side possible, what you will get is maximum perimeter, not the maximum area. So, for any figure, perimeter is the measure of the boundary of that figure. Perimeter is a one-dimensional quantity which does not bother about what is happening inside. It is just the measure of the boundary. But then area is a two-dimensional quantity which gives you the space covered by that figure. So you can have a triangle which has long sides, so long perimeter but small area, whereas you can see this triangle here, you have small sides, so the perimeter will be small but then area will be comparatively larger. Now let's start solving our question. So there you have a beautiful triangle. Two of its sides are 6 and 10. We need to find the third side for which the area is maximum. Let theta be the angle between these two sides. Then according to the sine rule, area is given by this formula, half into product of the sides into the sine of the angle between them. Now for the area to be maximum, sine theta has to be maximum. It is the only variable in the formula. All the others are constant. So the area is maximum when sine theta is maximum. What all values can the sine of any angle take? It can take values from -1 to 1. So the maximum value will be 1. So if sine theta is equal to 1, it means theta is equal to 90 degrees. One word of caution here. Sine theta is equal to 1 means theta can be any angle which can be expressed as 90 plus an integral multiple of 360. It can be any of these values. So why are we considering only 90 degrees? Because our theta here is not an angle of an octagon or a pentagon. No, it is an angle belonging to a triangle. So it can take only values from 0 to 180. That is strictly between these two values. So it cannot go to extremely small or extremely large values. So that is why we are sticking to only 90 degrees. So what do we see here? The area is maximum when sine theta is maximum and sine theta is maximum when your theta is 90. So what does that mean? Our illustration is wrong. For maximum area, the triangle has to look like this. The theta has to be a 90 degrees. Then applying the Pythagoras theorem, what will x be? It will be the square root of 100 plus 36. That means it will be 136. Now 136 lies between which two perfect squares? It lies between 11 square and 12 square, which is 121 and 144. Therefore, the square root of 136 lies between the square root of these two, or in other words, it lies between 11 and 12. There is only one option that satisfies that condition, which is 11.7. So that is the answer that we are looking for. Our third side, the maximum value it can take is 11.7. So that is all for today. Assalamu alaikum.